So, we have set up our classroom for inquiry and discovery based learning. We have researched our topics and planned our curriculums, structured our units, and planned our lessons effectively. We have devised our activities to where our students can interact with, with touch, sound, smell, whatever the cognitive stimulators are to allow them to be able to learn more effectively. But how do we know what it is that they've learned? Have they mastered the content? And I'm quite sure that most of you will have a good understanding of this topic already, and I'm going to hit it pretty quickly from your elementary education courses. But assessment is a critical piece, a critical component of the scientific classroom. How do we make sure our students are gaining the knowledge and understanding the content that we are trying to teach them? The textbook starts out with a really funny example of a student asking at the end of a test or at the end of a course, what did you get? And the other student says, she gave me a C. And so that misconception is widely prevalent, even in higher education, that grades are given and that a student, not necessarily tied to a student's performance. So how do we make sure that when we are evaluating our students and assigning them a grade, that it is tied to their understanding of the content and their performance? Okay, so the first thing is to distinguish between the two different types of assessment, two different approaches. There is formative assessment and summative assessment. Okay, so both of them are important. Formative assessment is an ongoing process. It periodically provides information to the student and the teacher that addresses how well the students are doing and how well the teacher is doing in guiding those students and teaching those students. A summative assessment is a cumulative assessment that usually takes place at the end of either a unit or a topic or the end of a course, and it is a culmination is assessment that captures the quality of learning that the student has had in the entire unit or the entire course, and it is used to judge performance against a set of standards. Okay, so what are some of the assessment strategies that we can use, be they used for formative purposes or summative purposes? Either way, these are some of the strategies that we can use to do these formative or summative assessments. The first one that your book talks about is the prompt and rubric. Prompt and rubric. A prompt is a question that includes a statement about a task, how it's to be done, and directions on how to do it. So that the prompt gives you the directions. Okay, and then the scoring rubric tells you what criteria is going to be used to assess whether or not the how the whether or not the task was performed adequately or how the task was performed. I'm quite sure that you're very well familiar with rubrics. There is a guide. I think we're going to talk about this a little bit later in this chapter, but a guideline on preparing rubrics that we're going to talk about. But basically, a rubric just really gives you a series of criteria to help you to evaluate the level of performance. That was my. And the next is the performance assessment. And this is based on observations of the student's problem solving skills. You can either observe their performance in solving certain problems by directly observing them and making notes. You can give them worksheets You can have them to do lab reports, or you can have them to produce products such as posters. You can have them to role play through a scene or a scenario based on a problem, or you can have them to do recordings. And a lot of these are fun ways for the students to become more engaged and to own their learning. A very effective method of assessment is a portfolio. And this is where a student can, it's a collection of his or her work. And for younger students, this probably will be a physical portfolio. But for older students, this has become a very widely accepted learning strategy that is done electronically in the form of what's called an e-portfolio. And it's just basically a collection of everything that the student, the best of the student's work, tests, written reports, written observations, their drawings, charts, investigations, graphs that they produced during their investigations, anything that the students do, and anything that results from their investigations and hands-on discoveries can be collected in a portfolio. And this can serve not only as an assessment method for the students, but also as a reinforcement in a way for the students to keep up with what they've learned and to revisit the topics and reinforce their knowledge. Anecdotal records can also be used for assessment, and these are just basically a teacher's notes about a child's behavior. If a teacher gives a student a test or a quiz, that grades or assesses one form of the student's learning, but it doesn't necessarily allow for reflection on the student's attitudes towards science or physical performance with hands-on activities. And so sometimes just the teacher writing down anecdotal observations or notes of a student's behavior. For instance, your textbook gave you an example of a student who, what if a teacher overhears a student saying, "Oh my gosh, I hate science"? Well, you're not going to grade that student based on that statement that he or she might have made off the record to another student, but you're going to use that in your formative assessment to think about what it is that you can do as a teacher to change that student's mind, to give them more stimulation, to help to guide that student a little bit more, to help to provide better guidance to that student. So anecdotal records are a good way for a teacher to take down information based on students' behaviors and attitudes and things that cannot be assessed using the other methods. Effective development checklists. Okay, so this is another one of the things that a teacher can do to assess the students' behaviors and attitudes about science. You can do worksheets that are checklists that describe the comments that they make, whether or not they smile or frowned when you did a certain demonstration. What is their body language telling you about what they think about what's going on in class? How are they behaving in class versus the way they behave out of class? If you notice that these actions are only taking place in the classroom, then you may be able to associate it with being the student has a certain attitude about science. If you notice that the student displays the same attitude in and out of the classroom, then maybe that's just an artifact of their personality. But basically, if you accumulate this information over time as a teacher, as a method of formative assessment, then you can figure out how to better reach that student. Science conferences with students, with children. So we quickly forget that students they're able to tell you what they know themselves. So if you take the opportunity to sit down one-on-one or in a small group and talk to the students, you provide an opportunity for them to talk to you. And it might be one of the best ways to find out what it is that they're learning. They may not be good test takers. They may not be able to communicate it in on paper, but if you listen carefully and gently probe the students to find out what it is that they're learning, this may be a very good method of assessing that learning. Science notebooks. If you think about how disorganized a child can be, a very good way to provide structure for them is to require them to keep a science notebook, a notebook that is devoted exclusively to science. You let them personalize a notebook to their wildest imagination. You let them design their covers, and you have them to write in them each day, and you give them the time to do that. So at the end of the unit, then you'll give them the chance to discuss what they've written in their notebooks. This can be a way for them to, something that they can show to their parents on parent-teacher night or back to school night. But basically, it allows them to be able to use more of their senses in interacting with and reflecting on their content. There are a lot of resources on sites like Pinterest for different types of lessons that you can use to integrate with the students' note-taking time. There are little foldables and really neat little, I don't want to say crafts, but little nice little activities that you can do within a science notebook that are colorful and that provide a very good visual learning tool to help the students to recall information and to learn information, learn and recall. So consider those resources for ideas of doing a science notebook. Okay, so when you are analyzing the notebook entries for the student, you want to take a systems approach and see, basically not just, you want to try to systematically assess their learning, see if they are able to express certain ideas and to demonstrate that they have more than a nominal level of understanding. And the idea is for them to approach functional literacy. Okay. A science probe is another method of assessment that includes answering a simple. I'm sorry. It involves asking a question that seeks a two-part answer. And so the first part of the question that you're going to probe for requires lower order thinking skills. It kind of introduces this kind of a bigger picture, and it just kind of is just general. But the second part of the question is going to be the part that requires the student to demonstrate higher order thinking, that they have processed the foundational knowledge and that they can now engage in assimilation of that knowledge into higher order thinking. Okay, a children's self-assessment. This is where you're going to allow the child time to reflect on how they do in activities. And of course, you're going to provide guidance and stimulation. So ask them how well you think they did. Ask them key questions to help guide their answers and help to guide their self-reflection. We want them to become realist, and we want them to become adults who have the ability to self-reflect, to accurately reflect on what it is, how it is that they've performed in something. So this is a very good way to start to stimulate that development. One of my absolute favorite forms of assessment, not just of assessment, but of note-taking, is concept mapping. And I really want you to take a look at your book to see a visual diagram of how concepts are mapped. Basically, it's a structural method of, it's a diagram that identifies basic concepts. You start with a core concept and you start branching off from that concept and linking the core ideas together and showing the relationships. Um, I I think I'm going to give you a, an activity on this, because if you can use this concept mapping in not only just your assessment, but you can use this in your career as a teacher, in your career as a student, to be able to take better notes and to be able to assess your knowledge on something. If you're able to recall the relationship between concepts and topics, and you using a concept map, this is a very, very powerful tool in both learning and assessment. They use nodes and links, and I kind of want to kind of show you. Let me see if I can find a way to get my pen on the screen here. Okay. Okay, like I said, my topic area is chemistry. So let's say I am doing a unit on describing an atom. Let me see if I can get a new page here. Doesn't look like it. Okay, let me see if I can do it down here. All right, so an atom would be my central topic. And so I could draw a circle around it, or in a concept map, the more physical, the more you interact with it physically, the more colors and graphics and nodes you put on it, the more of your senses are engaged, and the higher the propensity is for you to remember the information. So let's say in atom we have a nucleus, and in the nucleus we've got protons and neutrons. Okay, and over here we also have electrons. Way over here we can say we have mass number, and we have atomic number. And then we can show our relationship now between atomic number and the number of protons. Atomic number is equal to the number of protons. So this is very crude, but I just want to demonstrate to you that it is a very, very powerful technique to help you to be able to visually represent the relationship between concepts. And I know that was a lot of talking, and hopefully I won't forget at the end of this lecture to put up some video links to where there are some really good explanations of how to do concept mapping. Okay, another form of assessment is creative assessment. And this is where you employ creative methods to probe your students' understanding. You're going to be creative and think creatively about ways that you can get inside the student's mind to assess their thinking and their understanding. Okay, and before you do that, you're going to want to, what is it? What are the criteria? What is it that that will demonstrate? What will show you that represents their understanding? Okay, so what about the traditional assessment strategies? We all know what these are. We've got the end of chapter assignments, which is what you guys are doing, quizzes, end of unit tests, research reports, activity write-ups, and standardized tests. Well, let's look at each one of these and look at the pros and the cons of each one. Used judiciously and chosen relative to the context of what it is you're trying to accomplish. A combination of these and the strategies that I just described in the beginning of this lecture previously here is going to give you a very, very powerful assessment strategy, but you have to know what each one is and what it is not, especially the traditional ones. Okay, an end of chapter assignment tells the student that you're serious about the content you're teaching, but it doesn't really tell you about what they know nor if they like science. It just basically tells you if they're able to answer the series of questions that you posed. Okay, so you're going to want to talk to the children about the purpose of the assignment and the reading they have done in order to increase the meaningfulness of end of chapter assignments. A quiz will tell a teacher whether or not a student can think fast and recall information quickly, but it doesn't tell you whether the student has a good deal of in-depth understanding or not. You want to use them in moderation, keep them short, and keep them focused. The end of unit test tell teachers, parents, and children how well they answered questions that were asked. It doesn't allow the students to express their thoughts, and in order to use them effectively, you want to cross-reference each item to the objectives of the unit that you've planned. Research reports. These lead children to think about topics and questions not observed or considered during class. I'm sorry, not considered during class. It doesn't extend and enrich your basic knowledge and attitudes. You want to make them meaningful and relevant to the children and something that that they're interested in, and make it in the context of a quest to solve an issue or a problem that's relevant to them. An activity write-up will tell a student what they have been thinking, talking, and writing about is important. You want to provide guidance in an activity write-up. In order for them to be more effective, you want to focus the student toward in their writing by asking clarifying questions. And the dreaded standardized test. These tests allow teachers to compare how well the children in their class are comparing to the national norm, but it does not allow students to be assessed through the hands-on, discovery-focused approach. In order to use standardized testing effectively, we want to help students understand that these tests are not designed to measure all that they have learned, and we want to teach them and that they teach test-taking strategies. Okay, now this is what I was referring to earlier in the lecture when I said, when I was talking about creating rubrics and scoring guides. There is a very good guide in your book to creating rubrics. Now, what a rubric is going to do is it's going to tell you, based on this criteria, how did a student perform? If they were able to achieve this, and this level, then the outcome is satisfactory. If they were able to demonstrate this, and this, then the outcome is poor. If they were able to demonstrate, if they were not able to, if they were not able to demonstrate this, and this, the outcome is poor. If they were able to demonstrate X, Y, and Z, then the outcome is excellent, etc. So you have a very good guide in your textbook of how to create a rubric, and I'm going to ask you to go and take a look at that. And I'm quite sure that most of you are already very familiar with this from your education backgrounds. But these are very, very useful ways to, for a test, you have a specific answer sometimes, and sometimes it's more open-ended. So if you have a more open-ended activity or a activity that allows for responses that are more open-ended, a rubric is a good guide to help you to provide structure and guidance for evaluating the performance on these types of activities. These are helpful when you are assessing a process like an inquiry-based process, for example, rather than just facts, like a test is testing for facts. But if it's more open-ended and you're evaluating performance in a process or something like that, then a rubric is going to be very beneficial. And I know I have not done justice to describing rubrics, and that's somewhat intentional because I don't want to spend a lot of time with it, because I'm pretty sure that this is something that you all are very familiar with, and I will guide you, direct you to your text for some very, very good examples. Okay, so a holistic rubric will provide a general assessment that is based on all of the criteria at once, whereas an analytical rubric will specify performance for each criteria that you specify. So a holistic rubric evaluates the activity as a whole, and an analytical rubric goes into specific criteria and evaluates each one of them independently. Okay, so each one will have the criteria, what the performance should be for the criteria, and a scale, a rating scale, that tells whether or not the criteria, that tells what the score is based on whether or not the criteria was met. Okay. All right. So that is the conclusion of chapter 6. This is, oh, sorry. This chapter was a summary of the different methods that can be used to assess student performance and mastery of a topic. All right, and I will see you in chapter 7. And I encourage you to look in your textbook for some very good quick checks and examples, A, of how to do rubrics, B, of how to do the concept mapping, and other very useful examples and activities that you can integrate in your own classrooms.